welcome back, please. Yes, this is a summary video on calculations involving limiting reagents. In the previous lesson, we have done how you can calculate a mass to moles, moles to moles, and how you can now convert from mass to mass a conversion. Now, in calculations involving limiting reagents, there are some certain things you have to take into consideration. One, what is a limiting reagent, or what is a limiting reactant? Two, what relationship does a limiting reagent or reactant has with the product? And three, how, if given the mass of given the masses of reactants, to determine the limiting reagent and use that in calculating the product. What are the procedure you have to follow? And the first question which I asked regarding a limiting reagent. A limiting reagent is that reagent or that reactant in a chemical reaction that runs out first. It runs out first. Alternatively, a limiting reagent or a limiting reactant is that substance that becomes used up first in a reaction. It is the limiting reagent that determines the product that is being formed, because others are in excess. If there are two, three, or four reactants or reagents involved in a chemical reaction, the one that runs out first or the one that becomes used up first is the one that determines the amount of product that is being formed. For example, this is a reaction. We have been asked how much of the sodium thiosulfate will be produced by reacting 100 grams each of sodium sulfite, sodium carbonate, and sulfur dioxide. Sodium sulfite, sodium carbonate, and sodium and sulfur dioxide, these are reagents, these are reactants. And they are 100 grams each in a reaction. You are told how much of sodium thiosulfate will be produced by reacting all these 100 grams each of all these reactants. The first thing you need to know, since we are told that all of them are 100 grams each reacting, the second thing you need to know is calculate their molar masses. If we want to calculate the molar mass of sodium thiosulfate, the molar mass of sodium thiosulfate will be sodium from the periodic table has the relative atomic mass of 23. And 23 times 2 plus sulfur from the periodic table is 32. The MRO will be 78. For sodium carbonate, 23 times 2 plus carbon, which is 12, then plus oxygen times 3, which is 16 times 3, will give you 106 grams. For sulfur dioxide, that is 16, and sulfur dioxide, that is 32 plus 16 times 2 will give you 64. For sodium thiosulfate, we have 23 times 2 plus 32 times 2 plus 16 times 3, a total mass of 158 grams. For carbon dioxide, we have 12 plus 16 times 2, we have 44. But we are ending at sodium thiosulfate. After calculating the relative molecular masses of all the species involved in the reaction, then we compare with their molar masses, with the mass that have been given. They said 100 grams each reacting. Automatically, if you look at them, since the masses given are the same, and then you look at them, their MRO, they are different. The one with the lowest mass will be the limiting reagent. The one with the lowest MRO will be the limiting reagent. We can now calculate the amount of sodium thiosulfate from the limiting reagent. It has only 64 grams. We consider it the limiting reagent. We consider it the limiting reagent because it's the lowest among all the other reactants. From here, we can now calculate the amount of sodium thiosulfate that will be formed. Why do we calculate it from here? It is a limiting reagent, and being a limiting reagent, it will be used up first in the reaction, and it is the one that determines the product. Secondly, if the reacting masses are not the same, initially you were given 100 grams, 100 grams, 100 grams. If the reacting masses are not the same, another procedure you will use will be you need to calculate the masses produced from each 100 grams. And in order to calculate the mass of sodium thiosulfate, the mass of sodium thiosulfate, which is the unknown, produced from each of these 100 grams of this, you need to do what we call mass to mass conversion. And by doing that, we need to convert the given mass into the moles, then convert the moles into the moles of sodium thiosulfate, and then multiply the moles of sodium thiosulfate by its molar mass. We will have the mass. For instance, we are taking first sodium sulfite. Sodium sulfite has a molar mass of 78, and the mass that has been provided is 100 grams. To convert it to the mass, to the number of moles of sodium sulfite, we need to divide the mass by the molar mass. And we will have 1.2 moles of sodium sulfite. But we need, in this case, we need to have the moles of sodium thiosulfate. So we need to multiply the mass, the moles of sodium thiosulfate that we have got by the mole ratio. And the mole ratio is what? The coefficient of the product divided by the coefficient of the reactant. So it is product all over reactant. The coefficient of the product divided by the coefficient of the product of the reactant. Coefficient of product divided by coefficient of reactant. In that case, we are taking 3 all over 2, and we will have the moles of sodium thiosulfate. The moles of sodium thiosulfate. Using the triangle, when you have the moles, in order to have the mass of that substance, if we use our triangle formula, we'll have to multiply the moles by the molar mass of the substance. And the molar mass of sodium thiosulfate from here is 158 grams. We will multiply it, we will have the total mass of sodium thiosulfate produced by 64 grams of sulfur dioxide by 78 grams of sodium sulfite. The mass will be 303.3 grams, 0.36 grams. We need to go to sodium carbonate. The mass given is 100 grams divided by the molar mass, which is 106. We have the 0.9 moles of sodium carbonate. To convert the moles of carbonate to sodium thiosulfate, sodium thiosulfate is 1 mole. 1 mole of this producing 3 moles. So we need to multiply it by 3. That's the mole ratio. Then we'll have 2.82 grams, moles of sodium thiosulfate. Having got the moles of thiosulfate, in order to have the mass of thiosulfate, we multiply it by its molar mass, which is 158. And the mass of thiosulfate that will be produced by sodium carbonate will be 445.5 grams. Finally, if you the last reactant was sulfur dioxide. For sulfur dioxide, what do? We need to have, since it was given 100 gram divided by 64, which is the molar mass, we will have 1.58 moles. In order to convert it into the mass of, to the moles of sodium thiosulfate, we have 4 moles of sulfur dioxide producing 3 moles of sodium thiosulfate. So it will be 3 divided by 4. That's the coefficient of sodium thiosulfate divided by the coefficient of sulfur dioxide. 3 divided by 4. And if we multiply 1.56 by 3 over 4, we will have 1.17 moles of sodium thiosulfate. In order to have the moles of sodium thiosulfate, the mass of sodium thiosulfate, we will have to use its moles multiplied by its molar mass to have 184.86 gram. 0.86 gram of sodium thiosulfate. This will be the mass. As you know, this will be the mass of sodium thiosulfate produced. It will be the mass of sodium thiosulfate produced by. It will be the mass of sodium thiosulfate produced by 4 moles of sulfur dioxide. This is the limiting reagent. And since this is the limiting reagent, the mass that will be produced when 100 grams of all the reactants react, the mass will be this, because it is coming from a limiting reagent. Once more, a recap. In calculating limiting reagent, you have to calculate the mass of the product that is being produced from the limiting reagent in a reaction. And how do you get the limiting reagent in a reaction? The limiting reagent in a reaction can only be got by converting its mass, by having or converting the mass given into the mass of the product. So if you look critically, we have 100 grams each. And if you look critically, there is 64, 106, and 78 grams. Obviously, sulfur dioxide with the lowest mass is the limiting reagent. So this is the product that is being produced from this. So once more, for you to do this, you have to be very careful. Look at the given, calculate the molar masses, use mass to mass conversion, and you will get your limiting reagent. Thank you very much for listening. Bye-bye.